Hello and welcome to this talk on water testing back to basics. My name is Colin Day from Lovibond Tintometer and a past president of the Institute of Swimming Pool Engineers. When I suggested this topic of back to basics on water testing, I was asked why go back to basics? Well, I think what we've seen over last year is that 2020 was a very difficult year, and we saw this sign too many times. But one thing it has told us is that hygiene is very important, and it's not only important with washing of hands and cleaning of surfaces, but it's also important with the quality of the water. And this includes the testing of the water. And sometimes I think people get a bit complacent about testing, think that they know it all, and testing seems to become a bit of a chore rather than one of the most important things. As I've often said before, a swimming pool without water is it's like a hole in the ground. Water comes into contact with every part of the pool, and water is the one thing that can cause quite a bit of damage if it's not controlled properly. So with that, I think good testing is now more important than ever, and therefore I think it's a good time to go back through the basics of testing, how it should be done, what we should be testing, etc. Which hopefully over the next 20 minutes or so we will cover. So why do we test? Just a quick reminder of why you're testing. The most important is to make sure the water is safe, to sanitize the water, to get rid of harmful bacteria, to make sure the water is comfortable for people to swim in or to sit in. And water that's not balanced can be quite uncomfortable, cause irritations, etc. To make sure there is sufficient treatment. Pool chemicals are expensive, and you don't really want to add too many if you don't need to. To look after the pool and plant. As I said, water comes into contact with every part of the pool, and water that's out of balance can be very, very aggressive. And for those of you who've got pools or hot tubs at home, you've made quite a bit of investment into these. So why would you skip on testing the water? So you've got to look after your investment. You've got to control the costs of the chemicals used, and you've got to be compliant with guidelines, especially those in a commercial situation. So what are the guidelines? There's quite a few you should consider, and these are mainly for commercial. The Health and Safety at Work Act is the coverall. The Management of Health and Safety at Work regulations is also one that covers the whole of the establishment. You should have a cost risk assessment for all the chemicals you're using. So that's anything from your chlorine, your sodium hypochlorite, right through to your DPD number 1 tablet. You should have a cost form for that. The HSE have published a book, The Management of Spa Pools, Controlling the Risk of Infection, another one you should consider. And then you've got the PUTAG Code of Practice, the PUTAG Pool Water Book, and PUTAG Technical Updates. And if nothing else, these are things you should be following. And you should have your own operating procedure. So they're the sort of guidelines you should have. And even in a domestic pool, there should be procedures you need to follow and to make sure everything's being kept up to date. Sparta itself also has some information, and Sparta, they say that bathers have rights. They have the right to be safe, they have the right to be comfortable, and they have the right to appealing water. You can't have any of these if you're not doing regular checks and testing. I won't read out the statement, but that's Sparta's statement of what you should do about pool water. So let's start with the basics. Get the equipment right. And for commercial pools, this is what Sparta say in their book, that operators should be trained. They should know what they're doing. They should know how to use the instruments. They should follow the manual. The system should be professional and accurate. So again, PUTAG say the kit should be comparators or photometers. Test strips should only be used for guideline purposes and not for reporting. Make sure the range is correct for the application. You don't want to be carrying out dilutions all the time because that becomes complicated, it becomes time consuming, and it can lead to errors. It should use a recognized test system, i.e. if you're measuring chlorine, in reality it should be DPD based at the moment. Everything should be scrupulously clean. That's a direct statement from the PUTAG book. They should be checked regularly. That's difficult, but the bottom picture there shows you some little check standards that are now available, so you can make sure your photometer is still within calibration, and that can be done on a weekly basis. Don't need to send it away. You should use the correct tablets and check that they are in date, and the tablets really should be from the manufacturer of the kit that you're using. And you should consider how chemicals may react with others. So don't just put one in. If you put some chlorine in, it's probably going to make the pH go up. So you need to add some pH adjuster to bring it down. So considering how they may react. And for domestic testing, as I said, you've already spent several thousands of pounds on your pool or hot tub. So you do need to get the testing correct. You need to make sure the water quality is correct. So the first thing is to get something that you can use and understand. Don't get something that's too simple that you can't actually read it, or don't get something that's too complicated that it becomes a little bit daunting. As I said, consider your investment. If you've spent several £1,000s on a pool or hot tub, is spending a few pence on testing really looking after your investment? Consider the kit that you need. Decide on the accuracy that you want. Decide on the parameters you want to measure and understand them. And we'll go through what the parameters are later. Options are as follows. You can have test strips, as in the top picture. They are quick, but sometimes difficult to read. You can have comparators, as in the second picture. There's various different sorts available. Again, these are slightly more time consuming and still would require measurement by eye. And then you can have some sort of photometers, and these vary from 100 odd pounds up to several £100s, but they actually give the reading to you directly. So again, decide which one's going to be best for your application, your needs. And have a testing regime. Even in a domestic pool, you should have a regime that says when you're going to test, and you should always test before the initial use on any day, just to make sure that basically there's some sanitizer present. And always follow the manufacturer's instructions. Never guess. So let's have a little bit look at some good practice now when you're going to do some testing. General rules are take the sample from the pool or the main body of water if it's a hot tub. Carry out the test straight away. The water is a living thing. It's a changing environment. If you take the sample and walk away and come back, it will have changed in that time. Use clean, dry equipment. Use a suitable location and equipment for the person who's doing the test. So if you're using some sort of comparator system, make sure the person's not colorblind. If you're using electronic systems that tend to have glass cells, use them away from the water. Don't cut any corners. If the test says it requires a reaction time of 2, 5, 10 minutes, follow it. It doesn't mean 30 seconds. It does mean what it says. Never, never, never handle tablets. Always follow instructions. And make sure the people, especially in the commercial side, know what the results mean. So read them, record them, and then react to them. And that reaction, if something's wrong, could just be telling a supervisor, but there needs to be some sort of reaction. So as we go back to taking the sample, some key points. You should take it from the main body of water. Should take it using a plastic container because you don't really want glass within the pool. Everything should be rinsed out several times to make sure any contamination that could still be in the container has been removed. If possible, a proper sampler should be used because it saves exchange of water as it's coming back to the surface. Around about an arm's depth to make sure you're getting a sort of representation of what's in the pool. Make sure you have enough to do the test that you want to do, and then carry out the test straight away. So some basic information there. The only time you wouldn't take water from the main body is if you was actually calibrating one of your controllers in a commercial pool, and then you would follow the manufacturer instructions on how to calibrate the controller. Some more good practice there for carrying out the test. Wash and dry hands. Sweat is a very good way of contaminating a result. Again, use clean, dry sample tubes, but even then rinse them out a few times to make sure any chance of contamination is eliminated. Fill appropriate number of tubes. Again, if you're using a comparator and it says fill 2 tubes, one as a blank, one as the sample, fill 2 tubes. Again, check the tablet, never handle. Use a clean crushing rod, allow time, correct lighting, and record the results and how to react to them. So just some more basic good practice. And after testing, once you've recorded results, empty and clean all the cells out and dry the equipment, return everything to the boxes. We've seen examples where the wrong tablets are put in the wrong box. The next person comes to use them, wonders why the results are strange. And if you leave the water in the vase, the tablets can carry on reacting with the air, and they can stain the glass or the plastic. So what should you be testing for? Well, there's lots of stuff you can test in pool water, but the basics are your free chlorine or disinfectant, your total chlorine, and from those two you get your combined chlorines, your pH, your total alkalinity, your calcium hardness, and your TDS are the 6 or main tests that you would be doing in a pool. Obviously, for free chlorine, if you're using bromine, then you would be measuring bromine. And along with temperature, if you have those results, you can do what they call a balanced water test, and that will be covered a little bit later on. So let's have a look at these tests, these parameters. Free combined and total chlorine. It's a disinfectant. It sanitizes the water. It kills bacteria. It eliminates waste products or neutralizes waste products. The level depends on your operating procedure. NOP is normal operating procedure, or the level depends if for domestic pools on what you've been advised by the manufacturer to set it at. There are two main types of chlorine: the free, which is the good stuff that's disinfecting, and there's the combined, which is the used and causes the chlorine smell and can cause the irritation. It should be measured regularly, and when I say regularly, I'm really talking about 2, 3, 4, 5, 6 times a day, depending on your circumstances. I said there are 3 formats: the free, the good stuff; the combined, the used stuff, which is not wanted; and the total, which is the above 2 together. And normally you would measure the free, you would measure the total, and you work out the combined by subtracting one from the other. So for the free, you would use the DPD number 1 tablets, and then you would follow that with a DPD number 3 tablet. So as I said before, total minus free equals the combined, and the combined is not wanted. What else do you measure? pH is the next important one in the pecking order, as it were. It's a measurement of how alkaline or acid a sample is. The general range of pH runs from 0 to 14, with 7 being neutral, above 7 being alkali, and below 7 being acidic. The accepted levels in pools is 7 to 7.6. Ideally, 7.2 to 7.4 is what's aimed for. Accurate measurement is essential, and it must be measured the same time as chlorine, because the two go hand in hand, which I'll show in a minute. Normally we're using phenol red tablets. These are an indicator that changes color between pHs of 6.8 to 8.4, so ideal for the pool water range. And the effects of incorrect pH, it can be irritating to eyes and skin, because the human body has a sort of a general pH range of around the neutral mark. So as you can expect, anything extremely acidic or extremely alkali is going to be irritating to people. Likewise, it can affect the pool surround, so it can aid corrosion or aid scale forming. So again, you need to keep the water in the neutral area to keep it again balanced. And it can affect how your chlorine works. And the next is an interesting graph that shows you, the green line shows you how chlorine efficiency drops as pH rises. So as you can see there, because of the way the human body works, we have a narrow range of 7 to 7.6, which we can work in. So even at a pH of 7, you're only getting 70% active disinfection. So if you have 1 milligram per litre of chlorine in there, what that means is really only 0.7 of it is working. Once you get up to 8, as you can see, it's down to 20% efficiency. So if you let your pH drift up, up and up, it doesn't matter how much chlorine you have in there, it won't be working. So as it says there, at a pH of 8, you need at least 3 times as much chlorine as a pH of 7 to do the same killing power. This is why chlorine, the pH has to be really, really well controlled. Next is the alkalinity, the third on the pecking order as well, and it's the amount of alkaline salts, the bicarbonates, carbonates, hydroxides. It's different to pH. pH is measured in pH values. Alkalinity is measured in milligrams per litre. The acceptable range is 80 to 200, but ideally you're looking at 80 to 140. If you've got your water going well and your treatment going well, you can test it once a week. If you're having issues, you may have to do that more often. And the alkalinity acts as a buffer to the pH change. So if your alkalinity is too low, you may get pH bounce, as they call it. So every time you add another chemical, such as chlorine, the pH goes up, and you then add something else to bring it down, and it bounces back and forth. So that's why you need alkalinity in there to act as buffer. And also at low alkalinity, some flocculants do not work as well as they should do. But I've seen sites where they tell, especially spa users, to concentrate on alkalinity, get the alkalinity right, and almost go as far as saying, don't worry about the chlorine and pH. I would disagree with that. The alkalinity needs to be right, but the chlorine and pH also need to be right. So don't sacrifice other parameters for the sake of alkalinity. Calcium hardness is the amount of calcium dissolved in the pool water. Waters need calcium in them, otherwise they start looking for it in fittings, etc. And used to be in old tiled pools, they would go for the grout and take calcium out of the grout, and the grout would crumble and the tiles would fall off. Even nowadays, pools without water will still, without calcium, will still start looking for calcium. So you have to make sure there is some in there. But like all things, if you have too much calcium in there, as you heat the water up, the calcium will be dropped and you'll get hard watermarks on the surroundings. And finally, it's the TDS, the total dissolved solids. It's exactly what it says in that. It's the solids that are dissolved in the water. Ideally, they should be 1,000 above the incoming water, but generally a level of 1,500 is an acceptable level. And the dissolved solids come from as you add chemicals, or people add chemicals to the pool in the form of sweat, etc., and they dissolve in the water and it builds up and up. And you can see the effects there of poor control, mainly from high levels rather than low levels, because low level TDS is fine. The thing about TDS, to dissolved solids, is it can't be filtered out. So if you don't control it by doing sufficient backwashing, it will build up and up and up. And if the level gets too high, you basically have to dump water to get it back to normal. And then finally, the balanced water. You can do this with the test you've just done. It's a simple formula to see if your water is corrosive or scale forming. It uses various parameters which are giving a value on an index. Those are the parameters that you would use. So the test we've gone through plus temperature. Interestingly, chlorine or stroke bromine levels don't affect balanced water. And it's an easy way to see if your water is corrosive or scale forming. So if you're having issues, what I would say is carry out a balanced water test, and it may help you identify where the issues are. There's my email address at the end, so if you need any further details on balanced water, please drop me an email. So doing a test, let's just quickly do one test using a photometer. Switch on the unit and select chlorine. Fill one clean cell with the pool water, place in the chamber, align the arrows and press the 0, and the instrument should 0. The reason you are aligning the arrows on instruments like this is so they're always looking through the same piece of glass when they come to do the reading. Remove the cell and decant most of the sample into a second clean cell. And then to the original one, with a few drops left in it, crush a DPD number 1 tablet using a clean rod. If there's a red color develops, you know that chlorine is present. Refill the cell with the original sample. If the color disappears, this is known as bleaching, and it indicates that there are very high chlorine levels. If you put the DPD number 1 tablet straight into 10 ml and there's high chlorine levels, you do not see any color, and your immediate thought is there's no chlorine. So this is why you have to follow this technique when doing a DPD number 1 test. Return it to the photometer, align the arrows, push the test button, and record the reading. That is your free chlorine level. To the same sample, you'd then add a number 3 tablet and crush and wait 2 minutes. Return it to the photometer, align the arrows, press the test button, and that's going to give you your total chlorine. And as I've said before, the total minus the 3 is your combined chlorine. So that's a proper technique for doing a total and free chlorine test. With these cells, and these examples are for Lovibond products, the cells need to be filled correctly to make sure the test is done correctly. And as I said, the arrows need to be lined up with the arrows on the instrument, again, to make sure it's looking through the same piece of glass when it's doing the test. And on our instruments, as it shows in the picture, there's a small O-ring that needs to be in place, and this stops interference from light from the outside. So testing in these times, as we said, it's now more important than ever to make sure your testing is correct. Indications are that the COVID-19 virus will be killed, or you can't technically kill a virus. It will be denatured very rapidly in well sanitized pool or spa water. So it's imperative that the water is well sanitized, the water is well controlled. So you may wish to tighten up on your testing procedures. You might want to test more often during the day to make sure, especially the chlorine and the pH levels are correct. You may consider running at a slightly higher chlorine level than normal. You may consider lowering the pH, as I shown you earlier, as the pH is reduced towards the 7 mark and the chlorine efficiency increases. At this stage, I would not say go below 7, because you want to keep the water in the sort of neutral stroke, slightly alkaline level. But don't forget, if you do drop your pH, you've got to take into account the effect on the balanced water, as dropping the pH and not making other adjustments could make it corrosive and cause issues. So if you do decide to lower the pH, make sure you do a balanced water test to see what the effects are. Ensure everyone is trained. The tests are carried out correctly. The tests are done on time according to your operating procedure, and people know how important the testing is. That it's not just I'll go and do the testing. It's an essential part of the day-to-day running of a pool. And use the correct kits. Make sure they are suitable for the person using them. Make sure they follow the PewTech guidelines for testing if it's a commercial pool. Make sure you understand them if it's a domestic pool, and that they are suitable for what you want to do, and that they are looking after your investment, and make sure they are calibrated. And don't let the chemicals become distracted. Allow them to do the job they're intended to. Reduce unnecessary contamination. So you might have to have a stricter hygiene policy for bathers. Encourage showering. In fact, make it compulsory that people have a shower before they come in. This reduces the amount of waste products they're bringing in and allows the chemicals to do the job that they're intended to do, which is neutralize the stuff as it's editable, not be swamped with suddenly an influx of waste products. Keep the pool surrounds and equipment clean. Again, they can be a source of contamination. They can quickly swamp the chemicals. And basically watch things more closely. Give the chemicals a chance. Don't let them become overwhelmed with a sudden influx of waste products. The end. Just remember, keep testing, keep control, and keep safe. If you want more information on general pool water, where we are at the moment, PewTech have a virtual conference on Wednesday the 3rd of March, and you can find details on their website, the address below. All being well, I'm now going to join you live if there's any questions, and if you're watching this on repeat, as they say, please contact me with any questions at the address below, and I will try and come back to you as quickly as possible. Thank you for your time. I hope you found this talk useful. As I said, it was designed to get back to the basics of water testing, why we do it, how it should be done, etc. So again, thank you for your time.